Well, hey guys, here we are in the next section of notes for the endocrine system. Today we're going to be discussing the adrenal gland and one other section. So adrenal glands are glands that sit on top of the kidneys. They come into two parts. And remember when we talked about the kidneys, we talked about a medulla and a cortex. Medulla being the inside, cortex being the outside. Well, the adrenal glands work the same way. The adrenal medulla is on the inside, and this is controlled by the nervous system. And the adrenal cortex are on the outside, and portions of this are controlled by ACTH from the anterior pituitary. Here you can look at that adrenal gland, and you can see that distinctive cortex on the outside and the medulla on the inside. And if we magnify that, you can see that there are different portions of this that are going to work with the different hormones. In the adrenal medulla, we have an inner portion of the gland. The hypothalamus initiates stimulation of hormone secretion in the adrenal medulla, and it produces hormones that allow for a short-term response to stress. This is the fight or flight response. Epinephrine or adrenaline and norepinephrine. Both of these are going to give you a burst of energy. They're going to send blood to your legs, to your arms. Everything about this reaction is for helping you either beat something up or run away from it very quickly. If you have an adrenaline surge, a lot of times you'll even feel it in your thighs. The adrenal cortex is the outer portion of the adrenal gland, and it produces hormones that provide a much more long-term response to stress. So these are used more in terms of if you were being stalked by something. If you think about way back when, if we were hunter-gatherers, the fight or flight response that we had with the adrenal medulla comes from, I'm being attacked, I need to get away to survive. The adrenal cortex is dealing more with this long-term effect, like you're being stalked. You may not necessarily have these moments where you need to beat it up, but you need to always be on alert. And so what these hormones are going to do is suppress your body's inflammatory response. They're going to regulate your carbohydrate, protein, and fat metabolism. In fact, these hormones are your glucocorticoids, things like cortisol and cortisone. And we know that this has a really major effect on your body because under stress, you release these glucocorticoids, which even suppress your immune system, which is why if you've gotten really stressed out for a test or you're really worried about something, you're more likely to get sick. So we have to be careful because of the long-term impacts of long-term stress. We also have some mineral corticoids, which regulate your salt and water balance. These are things like aldosterone that we talked about when we were dealing with the urinary system. So if you look at the adrenal gland specifically, what you're going to notice is that you have the hypothalamus, which is sending a nerve impulse to the spinal cord, which then sends sympathetic fibers out into the adrenal medulla, where we have epinephrine and norepinephrine being released. These are very quick acting hormones. We also have in the anterior pituitary ACTH, which is releasing, and then that is affecting a more long-term release of the adrenal cortex of these glucocorticoids and even mineralocorticoids. We can get some malfunctioning of the adrenal glands, things like Addison's disease, which is a hyposecretion, hypo meaning low secretion of glucocorticoids by the adrenal cortex, and it tends to be characterized by a bronzing of the skin, as you can see in these pictures below. We can also get something like Cushing syndrome, which is a hypersecretion of glucocorticoids, so it would be like always being stressed out. It causes your immune system to be suppressed. You might gain some weight, primarily in the trunk of the body, but not necessarily in the arms or legs. And you can look at this picture below where you can see the impacts of Cushing syndrome. The second place I wanted to talk about today is in the pancreas. This is a fish-shaped organ behind the stomach. And I want to remind you, we discussed the pancreas back during the digestive system because it makes a lot of those enzymes that are used in the digestion of molecules in the intestines. But it also has tissue that is part of the endocrine system. And it has two different types of tissue, specifically exocrine tissue that produces and secretes digestive juices. That's what we just talked about. but also endocrine tissue, which produces and secretes two specific hormones. One is insulin, which we secrete when blood glucose is high, so the blood sugar is too high, and it causes your cells to uptake glucose to lower that blood sugar. And glucagon, which is secreted when blood glucose is low, and it causes your body to break glycogen down from the liver and dump sugar into the bloodstream. If you want to think about how we would regulate blood glucose from the pancreas, what you're going to see is when we have a very high level of blood sugar, it causes the pancreas to release insulin. This insulin causes your fat cells, muscle cells, and liver cells to pull sugar out of the bloodstream and to store it. In the liver, it'll even store it as glycogen to be used later. Then, if your blood sugar drops too low, it causes your liver to increase or to secrete glucagon. This might be because it was too long between meals, or maybe you're doing a sports activity and you're starting to run out of that blood sugar that you need to be able to run your muscles, and your pancreas will secrete glucagon into the bloodstream. Glucagon then causes your fat cells to break down fat, giving you some sugar, but also causes the liver to break down that glucagon that we had earlier, or glycogen earlier, to form glucose that can be secreted back out into the bloodstream. And this is how we maintain homeostasis. We either secrete insulin when blood sugar is high, bringing those levels down, or we secrete glucagon when blood sugars are low to reduce it back up. So diabetes is a really great example of where we can have problems with the endocrine system. So diabetes is the inability to control blood glucose levels, and it comes in two different types, type 1 and type 2. It affects about 25.8 million people in the US. So general symptoms of any diabetes is frequent urination, unusual hunger and or thirst, an unexplained change in weight, blurred vision, sores that heal very slowly or even not at all, and excessive fatigue. The long-term effects of untreated diabetes can ultimately lead to blindness, loss of limbs, nerve deterioration, kidney, and cardiovascular disease. As I said, it comes in two different types. And type 1 is typically called early onset diabetes. And this happens when the immune system, typically in your teenage years, completely wig out and destroy the cells that produce insulin in the pancreas. And because of that, they lose their ability to produce insulin. And so in order to maintain blood sugar and allow the body to absorb sugar out of the bloodstream and into the cells, which we need in order to run cellular respiration, the patient has to take insulin injections, and they are dependent on insulin their entire lives. In type 2 diabetes, this is adult onset, and typically the pancreas is still producing insulin. It's just that those receptors for the insulin have become warped or no longer respond to it. This tends to occur in people who are obese or very sedentary. Usually diet and exercise can help with this, but you may have to have other medications involved. All right, thank you.